Okay, hello. Welcome to the 5th Technical Labs. We're going to be running on Debuggers today. Okay, cool. Unfortunately, Joe can't be here today, so I'm running everything myself. So if anything goes wrong, please let me know. Everything has been seeming to want to go wrong today, so it's very fun. I'm actually going to be back in 1 second. Okay, I did forget to grab my iPad for my notes. So, today we're going to be running on debuggers. Debuggers are great. They're really, really useful. And not a lot of people, they can do loads of stuff, and not a lot of people know everything they can do. So we are going to run through using debuggers in CLion today. CLion is JetBrains' C IDE. We've gone through like the basics of using IDEs before in the previous lab. And so here we're just going to be going into just using the debugging section. If you're more of a command line user, if you look at the notes on the website, we went through using GDB, which is the GNU debugger, GNU project debugger. And that is like the most popular debugger in the world for C. It's open source, it's great. And I recommend that if you want to use the command line, and you can do much more powerful things in the command line, but you don't often need to do them. I was planning to use GDB inside of CLion, but just before we started, CLion and GDB decided to fall out on my laptop. So we're going to be using Lldb, but pretty much everything is the same, at least what we're going to be going through. Cool. So let's go through what is debugging. So debugging is the process of tracking down and removing bugs in software. It may sound uninteresting to you, or at least not as valuable as like learning a programming language, but actually in real work, developers normally spend the same, or if not more time debugging than writing code, which is unfortunate, but that's just the way of software development is. So getting proficient and comfortable with debugging tools is important. It's a very important part of workflow. Okay, so debugging techniques generally fall into two categories. We call them sort of logging and using a debugger. Some people call logging caveman debugging, which I find very funny, but it definitely has its place. So if you've written basically any code, I'm sure you're familiar with the practice of logging, which is trying to work out what you're doing by just adding print statements everywhere. Just whenever you think there's something interesting, just print variables, print everything, and then from that, work out what you're doing. There's a quote here: "The most effective debugging tool is still careful thought, coupled with judicious placement of print statements." That's from Brian Kernighan, who was a person who wrote C and wrote this book, which we'll be talking about later. Okay. And that kind of logging is great. That kind of logging is everywhere. That logging definitely has its place. But sometimes it's just not enough, and sometimes using a debugger can just be quicker and more efficient. Okay. So what is a debugger? So a debugger is a tool specifically for debugging programs. So whereas logging is a general purpose thing, a debugger is a program specifically designed for debugging programs. And debuggers give you control over the program you're trying to debug. So they allow you to do things like stop the execution of a program, step through the program line by line. So you can sort of, computers go incredibly fast. You may want to slow it down just to show you can see what it's doing step by step to try and, get more understanding. You can inspect values of variables at any point, so you can, each time you step through, you can check all the variables. And you can alter the execution of a program. and then many, many more advanced features. There are loads and loads of debuggers. As we talked about earlier, there's GDB, the GNU Project Debugger, and Lldb, which is the low-level debugger. Those both work on C. However, there are loads of debuggers, and most languages have like their own debuggers. Python has the PDB, Java has the JDB. For C, there's a bunch, and then loads of other languages have their own. Okay, so, and so this may be intimidating. There's a lot of debuggers that you have to know. However, most debuggers either have the same interface based off the GDB interface, or very similar. So Lldb's interface is almost identical to the GDB's interface. Or even if they don't, they'll be very similar in how they work. And if you're using the JetBrains suite, like we recommend for most people, JetBrains has a UI for doing debugging, and it's pretty much identical no matter what debugger you're using, which is great. So you can just learn one debugging UI, and then you're good to go with all of them. Okay, so we're in the notes, we went through using the GNU Project Debugger on a C program, and I'd recommend you read through them. I think it's fairly interesting. And GDB is extremely widespread and extremely popular. A lot of other debuggers are based off GDB, and GDB supports all of these languages. Key in here is C++ and Arduino. I know first years are doing C++ and Arduino at the moment. The tooling for Arduino is pretty bad, and the Arduino debugger itself isn't great. And so a lot of people use GDB with the Arduino debugger, but setting up can be kind of complicated. But anyway, I digress. There is a debugger for Arduino. Okay, I don't know how to pronounce your name. Ayush? Pardon me if that's wrong. Most advanced IDEs do have a debugger. So what you're talking about there is a debugger. And yes, they do. And we're going to go through that. Most advanced IDEs, their debugger isn't always, like, for C, the support is more patchy because it's more complicated. But yeah, they do. It's true, but they are using these debuggers. They are just presenting an interface to these debuggers. Okay, so installing GDB. Installing GDB can be installing debuggers. Installing debuggers can be a pain. Debuggers grab control of another program, which can be incredibly dangerous if you don't want them to. And so they need a lot of privileges that can make them really annoying to install, hence my problems with CLion today and GDB. And so you're going to have to look online for tutorials for your OS and whatever debugger you want to use. However, most languages like Python and Java, if you install their development kits, they come ready with debuggers that have all the right privileges already. On Mac, you get Lldb pre-installed, and GDB is reasonably easy to install on Linux machines. I don't know about Windows, I'm afraid. Okay, so let's get to debugging. Are there any questions at this point? No, we're okay. Yeah, okay. So what we're going to be doing is we're going to be looking at a program here. The program is my solution to exercise, chapter 1, exercise 20 of the C programming language, which is this. This book came out in like 1988. It's like the definitive guide to learning C. But newer versions of C are out now, so I don't necessarily recommend learning from this, but this is where the problem came from. And the problem is we are taking a program that has been indented with tabs and replacing them with spaces. Just an example program. Okay, so let's just run the program and I'll show you it works. The code for this program is available in the notes. I wrote it a while ago. It's not incredible, so I'm sure it has loads of bugs, but forgive me. So if I write in code what it's going to do, so here I wrote in, I'm going to do it with loads of spaces, and sorry, it's actually going to replace those with tabs. It takes as thumbing the spaces and adds tabs. So here you can see it's, as I'm scrolling here, it's got tabs in there, whereas my original one had spaces. And it just prints out the same program. It looks identical, it's just replaced the spaces with tabs. Here you can see the code. Cool. And so then we're going to switch to debug mode. And in the case of C, what this is going to do is it's going to compile the program, but it's going to include a symbols table. I don't really want to go into what symbols tables are here. They're quite complicated. Basically, it associates, so when you compile code, you're taking your code and making it into machine code, or machine code, and the symbols table associates parts of the machine code with like lines in your program, and it associates variables in the machine code with variables in your program to make debugging possible. Normally you add the debug table by specifying the -g flag when you're actually compiling on the command line, but C-line will do that for us. Lovely. Okay, so the first thing we're going to do is we're going to talk about breakpoints. So basically what a debugger, so to start using the debugger in C-line, up here you'll see once you've configured a run profile, you can press the debug button. Okay, and then it's going to open up the debug screen rather than the running screen. Cool. And so what this is doing is it's running, in this case, Lldb. And Lldb is then running the executable we've made by compiling the code in a separate folder. It's running it as a sub-process, which it has control of. And so this means at the moment it's running normally. And so if we just do the same thing, it's just going to run normally. But what we can do is we can add, so the first thing we're going to cover is breakpoints. Breakpoints are essentially, what they mean is when you get to this line, just stop, halt the execution of the program because we want to have a little look at what the program's doing and how it's running. So for example, if I quickly talk to you about the structure of this code, it keeps running process line until we get an error. So process line, it just runs through each line and removes the spaces that begin. So what we're going to do is we are going to put a breakpoint at the beginning of process line. Okay? Then let's debug again. Okay, and you can see it instantly ran into the debug line code, and because it's the way I've programmed it. And you can see it's hit this line here, and it's going to, C-line is showing us the current variables. Okay? Okay. Right, okay. And then if we go to, so you can see the current variables that are stored in the program. So here you can see we've got spaces num and we've got current character. These are two variables that are within the program. C-line's just showed them to us. We also have the Lldb Console. So if you prefer to use consoles, here are the commands we can run. So we can also run something like info. I don't know what command is. Anyway, you can see the breakpoints that are available. The breakpoints are in there. We can run commands in the Lldb command line if we wish. Okay, cool. So we can, and then we can resume. So then we have options. Once we've broken, we have options. So we can, when you're debugging, there's two general ways you can continue execution if you don't want to just, so you can either just continue execution of the program and run like normal until it hits another breakpoint, or we can step through the program ourselves. So we can do something like a step over, and this means just go run until you get to the very next line of the program. Okay? So here we've got this spaces before character function. And so if we step into, we will go into that step, that function, this spaces before character function. Whereas if we step over, we will go straight over it into this line here. Okay, so if I do step over, you will see, oh, now it's waiting for input, because we started asking for input. Okay, and so then it's gone to this next line and it's halted. Okay, whereas if we debug again, you'll see we've stopped here again, stopped the same line, and we step into, then it's gone into this function. So step over just means go to the very next line in the program. So run until you hit the next line in this frame. We'll get to frames later. And step into means run till you get to the next line of code. That may be inside a function, that may be machine code sometimes. And so that's what step into and step over mean. And if you want to see what the equivalent is in commands, please go and look at the notes. Okay. All right. And what you can see here is at every point you can examine all the variables. So that's breakpoints, and we can, in IntelliJ or any JetBrains thing, you can add and remove breakpoints by clicking in the gutter. This is called the gutter here. And so if we run this, we will stop at all these points if I put some code in. Okay. And we'll be able to inspect values. Okay, so that's breakpoints. The next thing we're going to talk about is, what should we talk about next? Okay, so let's just talk about resuming execution. So this button here on the left will resume execution, just down here, and that will run until it hits the next breakpoint. Okay, so for instance, if we had a for loop and I wanted to check every time this for loop ran, we could just put a breakpoint at the top of the for loop and then continue execution, and it will hit the next line of, when it next goes through the for loop, it will hit that line, pardon me, and we can inspect it again. Okay, so that is the continue line. Cool. The other way we can continue execution, so once we've stopped, oh dear. So that's what I mean by sometimes you get launched into machine code. So let's stop on this print line here, line 21. Okay, I've got to put some input in. Something that will need tabs. Okay, and so we've hit this breakpoint because it's opened up again. We've got all our variables. You may not want to, so let's turn that breakpoint off. You may not want to step through, right? You may want more control. So what you can do is you can put the cursor somewhere. So say I'm going to put the cursor here on this printf statement. You can run to the cursor, which means it will find where the cursor is, and then it will just run until the code hits there. So this is more flexible than just adding breakpoints. You can run as much as you like, run until where you want. Okay, so that's running. Any questions about that? This is fairly simple. I'm sure most of you have done this before, or some level of this. Running to breakpoints, Cool. Let's move on to some more advanced things. Cool. Lovely. Okay, so one of the main things that you will use, especially in C. So in C, there isn't a very good way to examine the stack. So let's briefly talk about what the stack is. So in any, the vast majority of programming languages, you have functions, and you call functions sequentially. So a function can call another function. And then data is generated about like what parameters you called that function with, what functions you called, where you called it from, and these form stack frames. Okay, so you can look at my stack frames here on the bottom left. So these are two not part of my program. This is the debugger, I think. And then here's my first stack frame. So it's the main function. So my main function got called. And then this called process line. So this is the next thing on my stack. And in here, you can see all the local variables that are stored with these functions, with these stack frames. And so the reason this is especially useful for C is if you have something like a seg fault, you can, if you run it inside a debugger, when this program receives a seg fault, it will, instead of just crashing, pause execution. And then you can see, it will let you look at where you are in the program and what the stack looks like, so what the what functions were called by what lines of code. So you can see also it knows, you see this main.c colon 10, that means it was called in the main C file at code line 10. Okay, and that tells you the stack. So you can examine the stack. You can also examine what variables are on the stack. Cool. Okay, any other questions? So Sam, how does debugging in breakpoints work with multiple files? Normally it's absolutely fine. So if you compile with the -G option, if you're using the command line, or you just use JetBrains or a JetBrains program, because it all gets compiled down to one binary, all of the debugging information is stored in that binary, and so the multiple files are just dealt with completely fine. With multiple threads, it's much, much more complicated. We're not going to talk about debugging multiple threads here, because you can read many books on threading and debugging threads. You can see here that if we had multiple threads, you would be able to do a drop down here and select which thread, but not sure about that. But in answer to your question, it works absolutely fine. Cool. Okay. So we've talked about pausing execution and then stepping through. Yeah. So you can step through piece by piece and control the execution this way. The next thing you might want to do is alter execution. So say you've got a bug and you don't know what the bug is. You may want to change the way your program behaves to see if that resolves the bug. So let's put a breakpoint here. Okay, so my program's going to run, it hits this breakpoint, so it's trying to process the first line. And this program, if it receives an error while processing a line, it returns -1. So okay, here's the problem that I don't know what this is in. I don't know how to do this in LLDB. Okay. Anyway, what you could do normally is, okay, here we go. That's what we'll do. Okay, so in GDB, pardon me. In GDB, you can return a different value from a function. So in this process line function, I could return -1 instantly. It would skip all other execution of the function and just return -1. I'm sure you can do it here. I am not totally sure how. And that would alter the execution. right? Hopefully you can see that by returning an error, the program would do something else rather than what it would normally do. That's one way to alter the execution of a program. Another way is we can just edit the value of variables. So here the current character, okay, so we've run over here and it's told us the number of spaces is 0. But say we wanted to change this value, we could change this to be something else. So we could say 54 zeros. Okay, and this has updated this value, you can see here. And then if we resume execution, and then we look at the console, you'll see it's print out a load of tabs and spaces because we edited that variable while it was running, and it has changed what the program does. It's altered the execution. And we can do this with loads of things. There are more ways to alter execution, but a lot of them are more advanced. The most common way is just to edit variables and return, but I don't know how to return. If you want an example of returning, look at the notes. I did an example in there where I knew the command, but I don't know it here, unfortunately. You can also jump. Again, unfortunately, I'm not, because GDB wouldn't work, I'm not completely sure. Yeah. Apologies. You can jump, which means just set the execution to a certain line. So skip everything up until this line, and just start running from there. But I'm not sure how to do it in LLDB. The commands are very similar, they're just not exactly the same, and I'm not sure what they are. Apologies. Okay. So now we can talk about some more advanced features. Okay. Okay. I will link the playlist at the end of this lab. Okay, so something you can do with GDB that I'm going to talk about briefly here is you can do something called checkpoints, which means you'll be familiar with it from video games. So you can store the current state of the program and then run your program and go back to it later. Like in a video game where you have a level that you keep dying on, you can store a state, go, and if you die, come back and try again. So you can run from the same state over and over again to check different paths of execution from that point. Again, look at the notes for how to do it in GDB. I'm not sure how to do it in LLDB. It is possible, but I don't know the commands off the top of my head. You can enter LLDB commands or GDB commands in this terminal. This is the LLDB terminal. So you can see here, this is the list command, which prints the 11 lines around the current function. I don't have Joe to look up commands for me. Okay. I'm sure, yeah, LLDB has the same features. Cool. Let's talk about watch points. Watch points are one of my favorite things about debuggers, and not a lot of people know about them. So what a watch point is it's very, very similar to a breakpoint, except in breakpoints break whenever you reach a line, okay? Watch points will halt execution whenever the value changes. So here I'm just going to right-click on a function, on a variable, sorry, and say add to watches. There we go. There you go, add watch point. Okay? Cool. So now we have a watch point for current characters, and hopefully if I do this, okay. There we let's see why that's working. Again, sorry, I don't normally use LLDB, I generally use GDB, but it was arguing with me today. So execution, done. Why isn't that working then? Oh, it is. Yeah, I'm being an idiot. So here you can see this is the watch point symbol on the left rather than the breakpoint symbol. You can see we've set current character to the new value. And because we've set it, we've changed the value, it's stopped here. And indeed, in the next line, it's read the value, and so we've had another, no, sorry, it's updated the value again, and so we've had another watch point. It's stopped again. Okay, so this is a really useful feature. So, for example, if you had a for loop that was changing a value and you didn't know why, you wanted to see how the value changed over time, you can set a watch point for that value and then run through executions and just see how it changes over time and what code is changing it. Sam Briggs, do the debuggers in most languages have broadly the same features and work in the same way, at least at a basic level? Yes, for the most part. There is a few changes with like, C is not an object-oriented language. With things like Java that are object-oriented, there's a few more features you can do with that and a few features you can't. But most debuggers have almost exactly the same feature set, which is why why JetBrains can have the same feature set for nearly all of them, and why have the same interface, and why people don't tend to learn debuggers. You tend to just learn debugging, and then the actual interface doesn't matter so much. Cool. So that's watch points. Watch points are great. And as you can see when we had a look in Debugger at the watch point, how do I look at my watch points? You can change it so you can set watch points so they activate when things are values are changed, or when they're read, or both. Yeah. So this is the reason we're doing GDB is because it's like the mother of all debuggers, and most other debuggers have like a subset of GDB's features, or a a superset. Like they'll have that and more normally. Okay. Yep. Okay. So the most useful thing about debugging C is the reason we talked about we've gone for debugging C here is that you can make seg faults much more reasonable. So first years, I don't know how much C you've done yet. You've probably run into a couple of seg faults, but later in the year you'll probably have to do more C, and you run into seg faults a lot with C. And C doesn't have errors like other languages, so they can be very, very unintuitive. This program doesn't really have any opportunities for seg faults. But basically when C is running in a debugger, whenever you get a seg fault, instead of just printing crashed because of a seg fault, I think it's worth actually talking about what a seg fault is, just very quickly. A seg fault is what basically your C program tries to access memory that it's not allowed to access. So this might be because you've tried to access like the billionth item in an array, which is like memory way out of your program's area, and your C program isn't allowed to access it. But C has no way of handling that it's not allowed to do something. C doesn't have error exceptions, so C will just try and do it. And so then your computer will send a signal to your program saying it's tried to access a segment of memory it's not allowed to access, or a segmentation fault. Normally, your computer would just kill the program, and you'd have an error, and it would just say seg fault. But with a debugger, when the debugger receives that signal that it's had a segmentation fault, it stops it, it catches that segmentation fault, and it halts the execution of the program, so that then you can do everything that you would normally do. right, when you've got a halt. You can inspect the values of variables. You can inspect the stack. You can inspect variables. And you can see exactly what is the problem. If you use LLDB, lovely. So this is the BT command, this is backtrace. This prints the stack, backtrace, so you print the stack trace. And you can see this kind of looks like a normal error that you would get in Java or something. So once you've hit the seg fault, it will pause at the current execution that threw the seg fault, or caused the seg fault, and you can look at the code that's caused it, giving you more a useful error, so that you can inspect the code like you would do normally. Okay. All right, lovely. Okay, and as Sam Briggs was saying, I was saying to Sam Briggs, this is, you can use, the debuggers are similar across all languages, even though languages vary massively. The commands and how you can use debuggers is very, very similar. The interface is sometimes different, the way they work is vastly different, but the actual functionality is the same. Okay. So I think we're about done. If anyone has any questions, please feel free to send them in and we'll just finish up early today. Thanks to Dr. Russell Bradford, read through the notes for this if you want to go and look at the notes, so thanks to him. Soren Mortensen read through the notes and did some, added some extra stuff for us, and Joe made my English readable. Sorry for the problems we've had today with the debugging. It was working fine yesterday, but things seem to want to spite me today. Let's switch to this. And thanks for coming in what I'm sure was a very hectic time for you. Any questions? What I might do is... Where's Joe? Joe's out meeting someone today, so he can't. Where's the playlist? I'll send the playlist. Nope. What I'm going to do for you is just open up a Python program. This is from competitive programming at some point. So you can see some very quick and dirty code. And what I'm just going to show you here quickly is that you can, don't know why that's so upset. That's not right. Okay. I don't tend to use PyCharm, so. Yeah, okay. So here you can see that the debugging in Python is very similar. You can add breakpoints, same way. I think you can do, most of it's the same. Because IntelliJ is very similar. You can see we've got the same console, we've got the same debugging screen with the variables listed, and if we actually hit a breakpoint, we'd have frames. This code won't run because it's written for Python 3 and I don't have an interpreter installed. Cool. There is the Spotify playlist. It's a great playlist. I love it very, very much. Cool. Also, another thing, we are BCSS, I don't remember when, I think it might be on Sunday. We're running a just come and talk event, so people can come and have a chat to us. and I'm going to be there talking about anything technical labsy. If you want to have a chat to me for some reason, I'm reasonably friendly. It's a very long playlist. It's a great playlist. So please feel free to come along and have a chat. I'm also normally around in Discords if you ever want to send me a question or anything. Yeah. Do read the notes as well. They're better. Sorry, we had a lot of technical problems today, but the notes are very nice and clear. Yeah. Okay, I'll give you a couple more minutes to send in questions. Next week, we're not going to run a technical labs, actually. Have the week off. And then the week after that, I think we're going to run on SSH. So, if any of you are interested in that. I don't know how much C you guys have done already, so if you have any specific questions about debugging C, the source for this, by the way, for my information is I read the manual for the GDB, which is very, very long. So. Thank you guys for being very nice. Most complex we've done right now is structs. Structs are cool. What's my opinion on the best way to debug with an Arduino? The best way to debug, I haven't done any Arduino. Well, I've done it for my personal project. I haven't done it for coursework because I'm a CS and maths student. But when I have done Arduino in the past, what you can do is you can attach GDB to a remote process. So run GDB on your computer and attach it to the Arduino process, and then you can debug like you normally would, but over the Arduino connection, on the Arduino itself. Because the Arduino debugger, there is a debugger included in the Arduino software, but it's rubbish. And so I would use GDB because that's what I'm most comfortable with myself. Or loads of print statements. I've also done that in Arduino. Yeah. You can go a long way with lots of print statements. I recommend actually, if you are serious about print statements, do look into actual logging protocols and how to do logging properly, because it makes print statements a lot easier, and debugging with print statements a lot easier. And look into how to do good logging, because you can do a lot with good logging. And even things like with logging, you can set a severity level with a good logging library. And then you'll be able to filter via that severity level. So say, for instance, every time I set a variable, I just had an information level log, but then when I had an actual error, we would have a severe level log. Then when I'm looking through my logs, I can filter out all of the info stuff. If that's uninteresting to me, just get rid of it. And only look at the severe things to find out when the really bad stuff is happening. And you can do a lot of filtering with that, which is very useful. There's lots more you can do with prop logs. Yeah, so Sam, with the timing issues, that's exactly what you would use a debugger for, because debuggers are very lightweight, because they only attach to a process. They don't actually do anything inside the process. What you can do is you can simply not do any halting. This is really complicated debugging. There's a big feature set in GDB for every time you get to a line, just give me the values of the variables and then continue really quickly. And that is very, very efficient and won't really do any timing issues. And that's the way you would normally debug something like that. Gregor, I don't believe you. Yeah, and Sam, it's worth saying with print statements as well, on Arduinos, you're printing over a serial connection, which is very complicated and can be slow. And so that can be the issue there. Print statements on a computer tend to be very, very fast. But on a Arduino, they could be slow. Send it over a 20,000 hertz serial connection, something like that. 200,000 hertz serial connection. Something like that. Slow. Takes like millionths of a second. Takes ages. Yeah. I don't know why the tooling for Arduinos is so bad. I know they're very popular. But the IDEs and the debugging software is rubbish. I don't know why. Could be a lot better. There's really good software for Arduino. The language you use for Arduino is just C++ with some extra stuff and some stuff removed. There's loads of good tooling for C++, like GDB. GDB works with C++. And so I don't know why there's no good IDE or debugger. It's very weird to me. I know most people who do a lot of Arduino work they do use other IDEs because you can do everything the Arduino IDE does with other command line tools, one way or another. You can just write C++ and then compile it and upload the compiled code if you wish to do that. Works just the same. It's just a serial connection. Okay, all right. Thanks for coming out, guys. I'm going to head off. Send us a message if you have any more questions. Yeah, thanks for coming. I'm going to stick it on the thanks for coming screen for a little while if you have any more questions.